Hello, math application students. Here are your notes for this section. So we're going to talk about sequences that are geometric and about graphs and their tables. So in the previous section, we learned that to get to the next one, you have to multiply a constant value. So multiply by r, by r, by r, and we use this formula to get the nth term, where this would be t sub 1, t sub 2, t sub 3, t sub 4. And notice that t sub 4 has the exponent here is 1 less than the term that we're working with. Okay, so let's look at an example. T sub n equals 2 times 3 to the n minus 1. Okay, so let's figure out what how this would play out. Okay, so what happens if t equals 1? Okay, then I would have 2 times 3, and what we're changing each time is this value right here. Okay, so since we've got a 1, the power is going to be 1 minus 1. Well, let's think about that. If I've got 2 times 3 to the 0 power, well, anything to the 0 power is 1, right? So I've got 2 times 1, which is equal to 2. Okay, next one. T sub 2. Okay, so we've got 2 times 3. The power increases by 1, right? So now I've got t sub 2 equals 2 times 3, right? 3 to the 1 power is simply 3, and 2 times 3 equals 6. All right, let's do another one. If I've got, oh, that's not a good color. Okay. T to the third power, so 2 times 3 to the 3 minus 1. Okay, well, this power, 3 minus 1 is 2, right? So I've got 2 times 3 squared, which, well, 3 squared is 9, right? So 2 times 9 is going to give me 18. Okay, so we got 2, we got 6, we got 18. All right, let's do the other two. Okay, to the fourth power. Okay, t to the fourth equals 2 times 3 to the 4 minus 1. All right, well, this gives me 2 times 3 to the third, and 3 cubed is 3 times 3 times 3, which is 27. And 2 times 27 is 54. Now let's do the last one. And you might already start seeing the pattern. The last one is t to the 10th power, right? T to the 10th, sorry, t sub 10. So we've got 2 times 3 to the 10 minus 1. And so this gives me 2 times 3 to the 9th power. And 3 to the 9th power, I already did it on my calculator, is 19,683. So that multiplied by 2 is 39,366. Okay, so I'm going to take all of these values and we're going to do something with them. So here I've quickly copied them all down here. Now, what is the common ratio R? Okay, so we can see that from here to here, we multiplied by 3 times 3 times 3 times 3. Now let's just see this with a calculator. 2 times 3 gives me 6. That times 3 gives me 18. That times 3 gives me 54. That times 3, so to the 5th power would give me 162. Okay, so that's one way to figure out R, is to simply look at my formula and this value here is the r value. Now another way to figure it out is to do the second term divided by the first term, t sub 2 divided by t sub 1, and that's going to give me 6 divided by 2, which is 3. Or I could have done two adjacent terms. So I could have done t sub 4 divided by t sub 3. 54 divided by 18, we get 54 divided by 18, we get 3. So no matter which term I use, if I use two adjacent terms and divide the t sub 3 divided by t sub 2, if I take two adjacent terms, we can figure out r with that. Okay? So let's plot these points. Okay, so when t is 1, when n is 1, t sub n is 2. So it's going to be around there. Okay? When n is 2, t sub n is going to be about 6. Okay, around there. Okay, when n is 3, it's going to be 18. So up there, 18. And when n is 4, we're going to be at 54. And you might notice, is this making a straight line? No, not really. Because if you notice, if I connected all these dots, it looks like it's making, what kind of shape? It looks like it's making a curve. Okay, and that's the main difference between geometric sequences and arithmetic sequences. With arithmetic sequences, you should have noticed in the earlier lessons that arithmetic sequences made a straight line. Okay, and so our lessons here are going to be focused on what shape is it, and plotting some points, graphs, using graphs and tables. All right, good luck with your homework.